So did you manage to deal with that exercise? No one. But according to me, I think we managed to answer the question in the sense that if you can recall, that information is coming from somebody who was doing a study. In other words, he was conducting a study, and then he wanted to check whether age appears to affect diagnosis of depression or not. And then he considered 5 different age groups, starting from age 45 to age 85. However, in our case, we just managed to compare age 45 and age 85, and we found out that people at age 45 are more likely diagnosed as depressed than those who are at age 85. So in this case, it shows you that indeed age appears to affect the diagnosis of depression, but in a certain way. It depends on the group that we're using. If you are using maybe age 55, maybe you can get a different story or the same story. Okay, but in the case where you can find that age doesn't appear to affect the diagnosis of depression, it's when maybe when you calculate your proportion, you find that is 0. So that means in that case, age doesn't appear to affect the diagnosis of depression because we find it to be 0. But if you find a certain percentage, it shows that that age appear to affect the diagnosis. It might be less or more depending to the age group, isn't it? I think it's clear. So I gave another exercise for you to look at, the one that you said, what about if we're taking two proportions, P1 and P2? We start by P1 minus P2, which we normally do. If somebody starts with P2, then minus P1, are we still going to get the same results or not? And then we said, yes, we are still going to get the same results. Then others, they say no, but I ended up saying that just go and work at and look at it, whether you manage to get the same results or not. Is there anyone who managed to look at it? None.
For A, I got 27.674.
For which one?
For estimating the overall mean and variance of estimator of mean.
Oh, no, we were not yet there. I was asking whether you managed to check whether if you swap them, P2, you started with P2 instead of P1, and whether you're still going to get is what you are referring to, Charlie.
Are you still on chapter 4, sir?
No, we are in chapter 4, but now I was still talking about the exercise that I gave yesterday on chapter 3, on that exercises that we were doing, because there are those who are saying, okay, what about if I can start with P2 rather than starting with P1 and so on. So I wanted to find out from you whether you managed to go and verify that. But it seems as there's no one who managed to do that. So let's just quickly go to chapter 4, example 4.1, the one that you are referring to. Okay, so in that case, let me just go to window journal so that I can show you. Oh, let me just open the last one so that you can follow. Wait a bit. Okay. Yes, we are here. Can you be able to see it? That's example 4.1 that we've been looking for. So there is a given information there. We have a population divided into 3 different parts: town A, town B, and rural C. And then we have the population sizes for each. The same applies to the sample means for each, and sample sizes for each, and sample variance for each areas. Okay. So now we just want to answer the questions. The first one says what? Estimate the overall mean. That's the first one. We just want to estimate the overall mean there. That's number A. Estimate the overall mean. Remember, we are applying the stratified random sampling here. So now tell me the answer that you got. You said you got what? Estimated overall mean is what?
27.67.
Yeah, very good. That's it. So you have to use this formula: y bar st, which is equal to 1 over n summation I starting from 1 up to 3. Okay, ni y bar st. Okay. So which is equivalent to 1 over the n, capital letter N stands for the what? Total population sizes, isn't it? You add them together, they are going to give you what? 310. Okay. Then the population size for stratum 1 is what? 155. Then multiply by the mean, which is 33.90. Okay, then plus for town B 62, then multiply by what? 25.12. Okay, then plus for rural area C is 93. Then you multiply by the mean 19.00. Okay, then you close it, and the answer is 27.67. Is there anyone who got the different answer? None. Okay, it's fine. So now it says what? Number 2, estimate the variance of the estimator of mean. So in other words, you are estimating the variance of the estimated population mean, okay, using stratified random sampling. That's number B. Or it's not number B, rather, let's say this one is Roman figure 1, this one is Roman figure 2. So it's the estimated variance of the estimated mean, which is like this, isn't it? Which is equivalent to 1 over n squared. Okay, summation I is ranging from 1 up to 3 of ni squared ni minus ni, all divided by ni times sample variance of each stratum divided by n I. So this is the formula that you're supposed to use, isn't it? So which is equal to, so here it's 1 over 310 squared. Okay. So then it's 155 squared. 155 minus 20. Okay. Yes, it's 20. Then plus plus what? Oh, times, sorry, before this plus is times the sample size, which is 5,95 squared, because they gave us the what to call the standard deviation there. Then we square it to becomes a variance, then divide by what? By 20, and so on. And then the last one is what? So you will do them. This one is 93 squared. 93 minus 12 divided by 93. Then 9,36 squared divided by what? 12. Okay. Sorry. So, and the answer is what? The answer for those who did it, estimated variance of the estimated population mean. What is the answer?
1,97.
Hmm?
1,97.
Yes, definitely. 1,97. That is the estimated variance of the estimated population mean. Okay? That's number A. So, even though at number A they didn't ask you about the bound, but let's calculate the bound as well. Let's calculate the bound. It's very important. The bound of the bound on the error of estimation for the estimated population mean. Okay. So it's B. The bound on the error of estimation for what? For estimated population mean. In other words, it's what? Y bar ST. Okay. So that B now is equal to 2 times the square root of what? The estimated var of Y bar ST. Okay. So now you have already calculated the estimated var of the estimated population mean. So this is equivalent to 2 times the square root of the answer that you got there, which is 1,97. And the answer is what? For those who are using calculators,
$2.8.
2.8, just 2.8.
1.
Oh yeah, 2.81. That's our bound on the error of estimation. Okay. Just indicate this one for future. This one is lecture number 10. So that's a bound. Now, let's assume that the question says It's very important. If the question says find the estimate of a population, let's assume that the question says find the estimate of a population mean with approximately 2 standard deviation, bound on the error of estimation. Yeah, now let's suppose that the question says find the estimate of a population mean with approximate 2 standard deviation bound on the error of estimation. In other words, you have to find the estimate of a population mean. The estimate of a population mean is what we have already calculated here. Okay. The estimate of a population mean is this one. That is the estimate of the population mean. But the question says find the estimate of the population mean with what? With approximate 2 standard deviation bound on the error of estimation. So the formula that we are going to use is this one. So you have to use the estimate of the population mean. That is the estimated population mean. Then you said plus or minus, because here they're talking about what? 2 standard deviations. So therefore you're going to have 2. This is the bound, isn't it? Plus or minus estimated var of y bar st. You see that? If the question says find the estimate of a population mean with approximate 2 standard deviation. 2 standard deviation is like a confidence, if you're finding a confidence interval there. Okay. So in this case, it's going to be equal to what? You have already calculated your mean, which is 27,67. Okay. Then plus and minus. Then a bound, we have already calculated it. Now it's what? 2,81. Okay. So the rest you can be able to find them as well. That's it. So I wanted to introduce to you this very important aspect. 2 standard deviation bound on the error of estimation. So you have to write y bar st, which is the estimated population mean plus or minus 2 plus or minus a bound, okay, which is equal to that one. So you have to have that in mind. Okay, sorry. So now we know that it has been proven that the 2 standard deviation, it has been proven that the 2 standard deviation bound on the error of estimation is equivalent to approximately 95% confidence interval estimate. Okay. So when you are using this one, 2 standard deviation bound on the error of estimation, it's like you are using 95% confidence interval estimate. It has been proven that. I don't know whether you can just go and reprove it. but because it has been proven, that is why we're taking it as it is. So in other words, here, all gave the true parameters, which is less than 95%. So which is not necessary for us. I wanted you to know this information, that it has been proven that two standard deviation bound on the error of estimation is equivalent to approximately 95% confidence estimate. So those are the things that I wanted to introduce to you before we go to question number B. Any question? Okay, in the absence of any question, let's go to B. Answer number B. B says what? Estimate the total and the variance of the estimator of a total and place a bound on the error of estimation. Okay, so we just want to estimate the total or the population total. So the formula is what? Star hat, isn't it? Which is equal to n times a population estimate, population mean estimate, which is equal to what? So it's equal to what? 310, is it? Multiplied by 27,67, and the answer is 85. 85 what? Those who are using calculator, just calculate.
It's 8577,7.
Yes, very good. 8577, comma 7. That is our population total. Then, because we want to find a bound, before we find a bound, we have to find the estimated variance of that estimator, which is what? Var estimate of that estimated population total. Okay. Which is the same as var estimate of what? Ny bar st, isn't it? Agree? Which is the same as what? N squared estimated var of y bar st, isn't it? And then the population size is what? 310 square, then multiply by what? The estimated variance of the population mean is what?
1.97.
Okay, yes. 1.97. And what is the answer? It's
189. 189,317.
317. That is the estimated variance of the estimated population total. Then from there you go to the bound. Find the bound, which is b equal to 2 times the square root of the estimated variance of that estimator. Okay. And you have already calculated it here. So it's 2 times the square root of 189,317. And the answer is what?
870.21.
870.21. That is our bound. So now let's find the what? The estimate of the population total with approximate 2 standard deviation. So now let's find the what? The estimate. I just want you to know this. Estimate of a population total. With what? With approximate with approximate 2 standard deviation bound on the error of estimation. Okay, so it's given by tau estimate plus or minus what? 2 times the square root of the estimated var of that estimate. Okay, so this is the estimate of the population total with approximate 2 standard deviation bound on the error of estimation. And then you have already calculated the population total, which is what? Can't even remember.
8577.7.
Okay, 8577.7 plus or minus estimated var
It's 18936.4.
come again. The 2 standard deviation, the bound is what? 870. 870.21. Okay, then
Yes.
8577.7 minus 870.21 is what?
Seven 707.49.
7707.49.
Yes.
Okay, and what?
9447.91.
9447.91. So this is your, it's like a confidence interval. I know you know how to interpret the confidence interval. Can you say 95% sure that our value is between those ones? The what? The bound, the estimated population total will be between that. Any question? None. Okay. Let me just introduce another thing that is very important here. So you know that a bound on the error of estimation for population mean is given by B equal to what? Bound on the error of estimation for the population mean is given by B equal to anyone?
2 standard deviation.
Okay, 2 For what?
For tau.
We're talking about the mean.
For
Not
the
population total.
For
The-
population.
expected
You agree?
variance of the population
Yeah.
mean.
Yeah, this one. This is the one, isn't it? Remember, it's different from this one. Okay.
Yes.
It's different from this one. B equal to 2 standard deviation of var y bar st. This one is what? It's a bound of what? It's bound on the error of estimation for the estimated population mean. Yes. This one is the bound on the error of estimation for the estimated population mean. So this one is bound on the error of estimation for population mean. You must know the difference. First one is bound on the error of estimation. The
Sir.
other one, bound on the error. Can you mute
Sir.
your mic? Okay, thank you very much. The second one is the bound on the error of estimation for the estimated population mean. Okay, question?
Sir,
Yes.
Aisha, this bound are confusing. So can you try to denote? No, sir. Just that the bound on the error, the other one like we are doing two different things. Can I write it if I'm looking for the bound on the error on the estimated population? At least I'll write BST, maybe something like that. BY by ST to make it that one maybe you can write a headnyana to indicate or this are two different because if you have been doing this thing here bound we know is two square root of the variance of the bound which we are determining, so it should be specific because end
No,
up
it's
it's
what I'm
easy to make
explaining.
mistake. Yeah,
Okay.
explaining. Hey, but you can see the way I'm writing it is the same B, so
The
all
same B,
starting
but
we might mix up.
different is the here. All of them are bound.
Okay,
So
sir.
the difference is here. All of them are the bounds.
Okay.
So, but in a case, you can just indicate that this one is for Y. I don't know.
Yeah, that way is better.
I don't know. In my case, it's like I will be confusing more. But in your case, just put in such a way that you understand it.
Okay.
Yes. Any question? None. Okay. Let's continue. So I said a bound on the error of estimation for population mean is given by B, which is equal to 2 times standard deviation of a var of that estimator. Okay. Now, in this case, if you just want to find the var of that estimated population mean, you can find it, isn't it? You can square both sides. Do you get that? If you square both sides, you are going to get B squared, which is equal to 4 var of yt. Do you agree? We square both sides.
Sir, can you
So
repeat?
therefore, the var
Sir,
of the estimated population mean
sir,
equal to B squared over 4. Yes, I'm coming to you. Yes.
why are we squaring?
We're squaring both sides. We didn't do anything. It's the same thing. Our main idea is just to make var of that estimated the subject of the formula. For in case if you want to find the var, the subject of the formula, you want to calculate the var of the population mean, you can just use that formula as well. So the same applies to the bound on the error of estimation for the population total. Okay, let me say the bound. You see, these things will help you when you are calculating something in future. The bound on the error of estimation for population total. Okay. B, which is b tau if you want to specific, to var of that estimate. Remember, it's a bound on the error of estimation for the population total. It's not a bound on the error of estimation for estimated population total. You must know the difference between the two. Again, if you want to find the var of that estimator, so you can just square both sides. Again, you find out b squared is equal to 2, not 2, 4. Var of tau estimate, which implies that the var of that estimate will be equal to what? There's something here. Before you go to that one, let me before you go to that one, sorry for that. So this also equal to 4, and you know that the var of tau is like what? Var of n y by st, isn't it? You still recall? Okay, and then this is equal to 4 times n squared, the var of y by st. Okay. So now, if you want to put var of that estimator, can also be equal to b squared over 4n squared. So that means you can just find it from the what? The population total as well. So var of that one is this one for the population total. For that one is that one. So in this case, you don't have a population size, so you can use it. But if you have a population size, you can use this one. So this is something that I wanted to introduce to you. So I think you can stop here. Unless if you have any question. So I think we are going, I don't know whether it's in the tutorial session, question set, you're going to find something related to this one, or we are still going to do it in the one of our lectures. It will depend, but I think there is some way you are going to apply this one, these things. So I'll check which one, whether it's there on the tutorial or we are still going to face it in the future on the lecture notes. Any question? So before we call it a day, remember next week you are going to have a long weekend, isn't it? There is a holiday on Tuesday, and you are going to come back maybe Wednesday or so, and then you are writing a quiz on Thursday. Are you aware?
Yeah.
Are you aware that you are? Yes. I just want to remind you that a quiz on Friday, and on the next week, the other Tuesday, I think, you're going to write a test, your first test. So you're going to write a quiz on Friday, then 3 days or 4 days after, then a test. So you have to balance. But anyway, the scope is still the same. The scope of a quiz and the scope of a test are the same. So if you are studying for the quiz, you're still studying for the what? For the test. So the question is,
Sir.
are you ready? Yes.
So, sir, that formula